I am Anil Kumar. Welcome to my series on partial fractions. Let me also thank all the viewers and subscribers on my YouTube channel. Because of their active participation, we have 200,000 subscribers today with 20,000 videos. In this video today, we'll discuss about I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss about partial fractions. We'll talk about some solution techniques which are very useful to write rational functions as sum of partial fractions when we have some special cases. That is to say, when we have improper rational expressions. In part 1, we discussed about proper rational functions, converting them to partial fractions. Now here, this is our part 2, right? This is part 2 in which we'll discuss how do we take care of rational expressions which are improper. Now when I say improper, it means what? It means that the degree of numerator is not less than the degree of denominator. So it could be same or higher. So if it is same or higher, then we do need to divide the numerator by the denominator and write it as a proper rational expression and then work on it, right? So that's why these examples are special. So we'll learn some special techniques. We'll see how division is performed when we talk about rational functions, and we'll also consider few test practice questions. So we are starting with 4 since we had 3 examples earlier in part 1. Now, the very first example is kind of special here. We have a quadratic expression x squared plus 2x plus 3, which is irreducible quadratic factor. So if you have that kind of a quadratic factor in the denominator, then how do you break it up in smaller parts? That is extremely important. So let's try to understand it. Now, if we have something like this, in that case, we could write this as a over the linear factor, which is x plus 1, plus the other one is quadratic. So we could write this as bx plus c. So we have a linear term in the numerator. Do you understand? So that is how we have to write this. Now the idea is to find the value of a, b, and c. Correct? In part 1, we had all factored linear factors in the denominator. So here we have slightly different cases. Okay. Now in the second case, which is 2x plus 3 divided by x plus 5, we could definitely write this as what? So here, since the degrees are same, we need to divide this, and therefore we can write this as some constant plus a over x plus 5. You get an idea. Now, in the sixth example, we have two quadratic polynomials in numerator and denominator, right? Now, in this case, if you divide, then again, the quotient will be of the degree 0. That means a constant. So here again, we expect a constant, and then we'll get a factor here in the numerator, which will be of the form of ax plus b, right? As you can see, denominator can be factored. Is that clear to you? So first step is to write this in some form. We don't know what this will be. Let's say px plus q after division. And then we'll get this 2x squared minus 9x plus 4. Now 2x squared minus 9x plus 4, it can be factored. 4 times 2 is 8, right? And minus 9 means minus 8 and minus 1. It can be factored, right? So it can be factored, therefore we could write this in partial fractions. The last one here is we have a cubic equation in the numerator and the denominator is quadratic. So in this case, well actually when we divide, we get a linear quotient. So here it will be like px plus q plus something else, right, in the numerator, and the degree will be what? Degree will be 1 less than x squared plus 7x plus 10, 1 degree less, right? So let us say it is ax plus b, right? So we'll have that kind of remainder, and then we still divide remainder with the divisor 7x plus 10. Do you understand? So this is what we are going to do after we do division. So in these three cases, we notice that you can divide the numerator by the denominator, right? So in these cases, let me write down here, you need to divide numerator by denominator. And then do partial fractions. Is that clear to you? Okay, so we'll also see how we did in part one. So that process will be repeated. Okay, so let's begin with our very first example, which is example 4. So as I said, in this special thing is that the denominator is something which cannot be factored, right? So we have irreducible denominator. So 5x squared plus 6x plus 5 over x plus 1 times x squared plus 2x plus 3 can be written as a over x plus 1 plus bx plus c divided by x squared plus 2x plus 3. Now first step is similar. We'll multiply both sides by the common denominator, which is all this, right? So we'll multiply the whole thing by the common denominator, which is x plus 1 times x squared plus 2x plus 3. Now when you do so, on the left hand side, you get 5x squared plus 6x plus 5, correct? It cancels. And on the right hand side, cross multiply, right? So you can see how it gets cross multiplied, right? And then you get your result as shown here. Perfect. Now, at this stage, you could adopt either of the two methods. One is that you can expand and then compare the coefficients. And the second one is you can substitute convenient values for x. So we adopt our method of substituting the values for x. Now let's look into it. What will work for us? Well, as you can see here, x plus 1, it can be 0 for x equals to minus 1. Do you see that? So if I substitute x as minus 1, in that case, bx plus c will be multiplied by 0 and whole term will vanish. We can find the value of a, right? So we'll substitute x equals to minus 1 to find a. Is that clear to you? So that is the whole idea. So as soon as you substitute minus 1, on the left hand side, you get 5 minus 1 square plus 6 minus 1 plus 5. And on the right hand side, a times 1 plus 2 times minus 1 plus 3. Now when you open this, you get 5 minus 6 plus 5 equals to a times 1 minus 2 plus 3. And solving, we get on the left hand side 10 minus 6, which is 4. And on the right hand side, 1 minus 2 is minus 1 plus 3 is 2. So 2a. So therefore, the value of a is 2 for us. So we got the value of a by substituting x equals to minus 1. Is that clear to you? Now, to solve further, we need to find the value of b and c. There are two unknowns. So we should look for two different values of x. X equals to 0 is the most convenient value to apply. So I'll suggest always try x equals to 0. Now when I substitute x equals to 0 in this equation, on the left hand side, the two terms with x vanish. We have 5. So we are left with 5 from the left hand side. And on the right hand side, we get a times 3 and plus c times 1, which is c. So now, after substituting x equals to 0, we get 5 on the left side and 3a plus c on the right hand side. We already know the value of a, which is 2. Substituting 2 for a, we can now find the value for c, right? 5 minus 6 is c, so the value for c is minus 1. Is that clear to you? So we have found two things. One, the value for a. Another thing is c. The only parameter which we need to figure out is b. So let us substitute some other value for x. 1 is again easy for calculation. Substituting 1 in the equation which is given to us, we get 5 plus 6 plus 5 equals 2. 2 times the value for a, right? So we know a is 2. That is a value, correct? 1 plus 2 plus 3, b minus 1, right? So b times x, x is 1, therefore we wrote b. And here, c is substituted with minus 1, correct? So it was b times 1, and then we had plus c, right? So instead of c, we are substituting minus 1, so we get b minus 1 in this particular case. Is this clear to you? Right. Now, the only unknown is b. Open the brackets, simplify, solve for b. So you get the value of b as equal to 3. Once you get that, you can always substitute a being 2, right? This is the value of a. That is the value of b, which is 3. And this is the value of c, which is minus 1. So you get the rational expression in the form required. Is that clear to you? Have a good look at it. Understand the whole process, okay? Now let's move on to our special cases where the degree of numerator is not less than the degree of denominator. So these are improper rational expressions, right? So let me write down here. They are improper. Now in this case, we could divide the numerator by the denominator. So we will divide 2x plus 3 by x plus 5. So we have 2x plus 3 here. That's our standard division and long division, right? Dividing by x plus 5. Let's take care of the leading coefficient, which is 2. Here it is 1. So multiplying this by 2, we will get rid of the leading term. So in the quotient, we write 2. 2 times x is 2x, 2 times 5 is 10. And when you take away, what do you get? You get minus 7. And therefore, 2x plus 3 divided by x plus 5 can be written as 2 minus 7 over x plus 5. And that is the required answer, right? So we're done partial factoring of this very easily. Well, here is an alternate method for you. You will also split the numerator and then do without long division. Sometimes tricky, but is a very efficient method to work with. So try it out, right? We basically want to cancel x plus 5 with one of the terms. Since there is 2, definitely we could take 2 times x plus 5. But when I do so, what do I get? Well, let's look into it. What is 2 times x plus 5 equals to, right? It is 2x plus 10. However, we have only 3 here, not 10. So, what can we do? Take away 7, right? So basically, what we did was, think like this. We did 2x plus 3, we added 7 and subtracted 7. Do you see that? So these three terms combine to give you 2x plus 10, which could be factored. So that's the trick, that's the strategy. If you understand this, it could be handy many times. Okay, anyway, if you do that, you do get a factor like this, which could be written as 2 times x plus 5 over x plus 5 minus 7 times x plus 5. It cancels and you get 2 as a whole number right there. So that becomes a rational expression, right, in a simplified form. I hope you understand both the methods. Okay, so it's your choice. You can do long division or the alternate method. Most of the time, we have to perform long division. It is faster and much easier. Here is example 6. I'd like you to pause the video, try it out. We have the question, which is 4x squared minus 16x minus 7, 2x squared minus 9x plus 4. Since the degrees are same, we can divide the numerator by the denominator. So we have done that. The leading coefficient is 4, so 2 times 2 is 4, so 2 goes in the quotient. Multiplying each term with 2, right? Multiplying each term with 2, we write down right there and then take away to get the remainder. So in this case, the remainder is what? Well, the remainder is 2x minus 15. So that comes as the numerator for the rational expression, and the quotient becomes the whole number which is written there. You could write 4x squared minus 16x minus 7 divided by 2x squared minus 9x plus 4 as equal to 2 plus 2x minus 15 divided by 2x squared minus 9x plus 4. Is that clear to you? So that is how we are going to do it. Now, let us factor the denominator, right? So we'll first factor. As I was saying, we're looking for product and sum, two numbers, P and Q. Their product should be what? Well, their product should be 4 times 2, which is 8, right? So we are looking for a product which is 8. And their sum should be minus 9. So the two numbers could be minus 8 and minus 1. That gives you minus 9. So we have split the minus 9x terms into two parts, minus 8x and minus x. Now combine the first two and the last two, and then you can get the group factoring done. So x minus 4 times 2x minus 1 becomes the product to give you the result. Okay, so therefore we could write this rational function 4x squared minus 16x minus 7 divided by 2x squared minus 9x plus 4 as equal to 2 plus 2x minus 15 divided by 2x squared minus 9x plus 4, right? Now, the right hand side can be written as a over x minus 4 divided by b over 2x minus 4, since the denominator can be factored as x minus 4 times 2x minus 1, correct? So the whole idea here is to now repeat the process which we learned in part A to further factor. So let's continue with this. So we'll see how do we simplify 2x minus 15 over 2x squared minus 9x plus 4. Well, it could be written as a over x minus 4 times b over 2x minus 4. First step, multiply both sides by the common denominator, which is 2x squared minus 9x plus 4. So on the left hand side, you are left with 2x minus 15. And on the right hand side, it is like cross multiplication, right? A times 2x minus 1 plus b times x minus 4. Now, we will take two values of x, one which will make one of the factors 0, the other one which will make the other factor 0, and then find the value of the constants a and b as shown here, correct? So you can have a good look at it. When we substitute x equals to 4, we get 2 times 4 minus 15 equals to a times 2 times 4 minus 1. The other factor is 0, right? Here 8 minus 15 is equals to 7a. Dividing minus 7 by 7, we get a as minus 1. On the right hand side, we're going to substitute x by half, right? Substitute x by half. And then we see that the first term, which is a times half becomes 0, right? And so we can find the value of b, and b is 4. So therefore, we have factored and got the values of a and b. And now we can write down our result, which is 4x squared minus 16x minus 7 divided by 2x squared minus 9x plus 4 equals to 2 plus. So since a value is minus 1, right? A is minus 1. So we wrote minus 1 over x minus 4 and b is plus 4. So plus 4 over 2x minus 1. Is that clear to you? So we'll take another question which is kind of similar. Okay, so this time I'd like you to pause the video and answer this question. We have a cubic polynomial. In the numerator, denominator has a quadratic equation. So when you divide the cubic polynomial by the quadratic, you'll get px plus q as the quotient, and the remainder will be then factor as shown here. So let's do the division first, writing x cubed plus 5x squared minus 2x minus 19 divided by x squared plus 7x plus 10. So compare the coefficients. Well, you should multiply by x to cancel away x cubed. And then once you take away, right, so you should perform this and check the result. You get minus 2x squared minus 12x multiplied by minus 2. Remainder is plus 2x plus 1, right? And now we could write this particular function as equal to right shown here. Is that clear to you? Quotient of x minus 2 and remainder of 2x plus 1, right? Now this part 2x plus 1 over x plus 5 x plus 2, we have to figure it out. So here are the details given. We did it earlier also. So 2x plus 1 over x plus 5, it could be written as a over x plus 5 plus b over x plus 2. Now multiply each term by common denominator, cross multiply, write down your expression, substitute the values. The two values of interest should be x equals to minus 2 and x equals to minus 5. This is x equals to minus 5, that is x equals to minus 2. Substitute to get the values for a and b respectively, correct? Once you get this result, substitute them in and write down the final answer, correct? So that becomes the solution. Is that clear to you? So with this, we have actually solved these questions very easily. It looks simple when you see the solution right in front, right? Okay. So here is a test for you. So I'd like you to actually complete the test and submit your solution. To my email address given here. If I receive your solution, then I can always share with you the right solution, or we can discuss anything if you want, right? So here are 4 questions. Question number 1 is very simple, x minus 3 over x plus 8. I'd like you to do in 2 ways, right? So do it in 2 ways. Second one is x plus 5 divided by x plus 1 times x minus 3 whole square, right? You can write this as what? You can write this as a over x plus 1, correct? Plus b over x minus 3 plus c over x minus 3 whole square, correct? So you need to write some values of x which will make these factors 0. Third one is, you could write this also in this particular fashion, a over x plus 1, sorry, 1 minus x it is, okay, plus b over 3x plus 2 plus c over 3x plus 2 whole square, right? So a lot of calculations in question number 3. Have a good look at it. Now, question number 4 is slightly tricky. I'd like you to understand this particular question and then solve. I've also given solution in one of my videos. The reference of the link is given here. So You can check that out. Or you can always search in my YouTube channel. You can write Anil Kumar partial factor. And look for some more videos which can help you answer such questions, right? So this is extremely important question, the question number 4. It has been asked in previous test papers. I'd like you to do some research or look into its solution if you have difficulty. You can also send an email on the address given here. I can always share with you the solution of the question. I hope you understood and you enjoyed this particular uh, partial fractions process. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.